The title of our next talk is Browser Bug Hunting in 2012. Please give a warm welcome to Roberto Suggi Liverani.
Thanks everyone. Thanks for coming to this talk. I know you guys must be tired. It's 4 p.m. But I'll try to be as much as entertaining as possible. As being introduced, my name is Roberto Suggi Liverani, and the talk I'm gonna do today has been done with Scott Bell. It's my colleague. Unfortunately, he couldn't make it, so I'll try my best to do the part of his presentation as well. So where are we? We both work for securityassessment.com. It's a security company based in New Zealand. We do also have office in Singapore, and we both are principal security consultant. I have a blog, so sometimes, time to time, I publish my research, blogmarish.net. And yeah, so what's the agenda for today? The presentation structure is very simple. It's basically 3 different points. One is introduction, and then the window shopping, and conclusion. So I'll go into the introduction soon, but the main core of the presentation is the window shopping. It's like going through all the bugs that we found as part of this research. And it's kind of shopping experience, like we go to each bug and it's like going for shopping. It's like a window shop, and each bug is in a window shop. And as part of that process, I will share with you some fun and pain of discovering bugs and trying to exploit them. And of course, for each bug, I'll try to do live demo. So short introduction, why we choose to target browsers? Well, it's mostly because everyone uses browsers. And there's a lot of technology shifting into the client side. And once you find a bug in a browser, that's a cool bug because it's affecting so many people. So we took the approach of like wide angles, like we didn't just focus on memory corruption bugs, but also other kind of bugs. And when I say other kind of bugs, it's injection attacks, and also trying to defeat security controls in the browser, like same origin policy. And this is something that you would see soon. Okay, let's get to the core of the presentation. I just want to be very straight, so let's start shopping. Yeah, pretend you're there and you look at the window shop, and you see instead of looking at the shoes or the bags or whatever, you look at the logos of the browsers. So the first one I'm going to talk today is the Firefox use after free. That was found by Scott Bell and an ex-colleague of us, Blaze Strang. It's a memory corruption bug and has been fixed, Firefox 11. It only works in Windows 7. And we like to rate kind of the vendor response. So we like 0 to 5, and this is 3 because it took so long for them to fix it. It's a very long thread. If you check the Bugzilla entry for this bug, it's like a long thread because Mozilla developers really struggle to understand the bug and try to find the fix for the bug. But they fixed it, so that's a good side. So the approach we took to find this bug was to use Crossfuzz. So Crossfuzz is a public tool has been developed by Michael Zaleski. And basically it's kind of tool which can be used to fuzz browsers. But what was done in this case was to modify that, tweak it a little bit, and I'll show you what's done. So what type is this bug? So this is a memory corruption bug, and more in particular, it's a use after free. So the use after free occurs when the software is trying to use a part of the memory which has been freed. In this case, it's a heap chunk which has been freed. And you can see in the screenshot below the fee. Fee is the pattern which is put by the heap manager to identify the heap chunk which has been freed. And then you see the call on the bottom, and it's trying to call the pointer which has been freed. And of course, there might be different behavior, so the software might crash when this occurs, or it might actually behave in a different, unexpected way. So in this case, we try to execute code from the corruption bug. So what kind of modification we did on Crossfuzz? What you see on the right side is part of the parameters, which are part of Crossfuzz. And these are all parameters which can be changed. So one of the main change was to increase the entropy. When fuzzing with the parameters, you pass in Crossfuzz. And the other modification we did, we removed the toggle garbage collection function. And then also In the HTML template, which is passed to Crosspath, another major change was to set the document.design mode on, which is basically like setting the content editable attribute for each HTML elements on. So that makes the entire page to be editable. And with those changes, we actually noticed there were other crashes we couldn't find without having those changes. So it's quite interesting, and that's part of the modification. Other modification we've done is basically I created this tool, which is like a Python script, and it's called HTML Gen. And what it does is creates like a very complex HTML file, and it supports HTML5 or 4. And so what we did is combine this complex HTML file with Crosspath and see if we could achieve different results. The other thing which we noticed there was causing some problems is that you have to wait that the page is loaded completely in terms of the DOM. If the futzing starts before the page is completed, then it will always give different results. So if you have a crash, you might end up that you can't reproduce the crash anymore. So we had to do some kind of changes. And other things we did is like, you have different phases in Crosspath. So we tried to cut down some of the phases which we didn't want to have. And as you can see in the screenshot there, we just left like tweak properties, which is a function which just does change on the properties of HTML elements. So kind of modding that took a long time to get it working. And then we have the crash. So the next thing which we did was to minimize the crash because we were using a very complex HTML, as I said before. And Crosspath performs thousands of JavaScript operations against the DOM of the page. So the problem was to identify how many and which JavaScript operations are performed by Crosspath. So the colleague Bladestrain, he developed a Firefox extension. So the Firefox extension is called JSlog. So you install the Firefox extension in Firefox. And then what happens is that you run, JSlog can dump all the JavaScript operation performed by the Crosspath. And the way to do that is basically, there is a log function you see in the screenshot there. You create a custom event into the DOM, and basically JSlog is waiting for the custom event to trigger. And when the log function is called by Crosspath, it just initiates the event that JSlog is waiting for, and then logs the content of the operation. That allows us to actually make a huge list of JavaScript operations performed by Crosspath. And that's part of the minimizing the test case. So a lot of time was spent to minimize the test case, and just by going by consistency. So run the Firefox, attach the debugger and see if it was still crashing by making modification on the HTML template and then reducing the JavaScript as well. And that took a long time. And then, of course, the result is, after months, is to get to a simplified test case, as simple as possible, where instead of 1,000 JavaScript operations, you have few JavaScript operations, and instead of huge HTML file, you have a very simple one. So this is the proof of concept that I'm going to show. So basically, there are two files involved. One is the parent.html page. I don't know if you guys can actually see. Try to make the screenshots as big as possible. Basically, what it does, this opens a child window, and the child window, which you can see now, it's basically like a simple HTML file with a form and an input type file. What the parent does, it opens the child, spawns the child, then there's a set timeout function, in this case do close, which is triggered after 2 seconds. And then it clicks on the input file from the parent, and then it closes the child. So to make this very simple, I just try to picture. So parent spawns the child. The parent then calls the file, clicks on the form. That calls in Windows to spawn the file open dialog. And then the parent tries to close the child while the file open dialog is still open. That creates the crash. So it seems very simple to understand, but in order to get to that conclusion, we spent 6 months. So it's, yeah, it was not, I remember that Scott was ranting a lot about this. So let's analyze what happens in the crash. So what you see is a use after free, that's obvious. And this is the screenshot based on the crash of the proof of concept I just showed. And again, you see the direct call on the heap chunk which has been freed. Another interesting thing is the Stackframe at the moment of the crash. So what we noticed here is that the yellow part is all like Mozilla land functions. And then, but what you notice is on the top, which is the last function which are being called before the crash, it's all Windows libraries, user32, shell32, and then the crash occurs in the SHLW API. A kind of indication that something was wrong with Windows rather than Firefox. So the conclusion is this is kind of race condition bug because it's not that much reliable because it depends how the timing which is used to close the child window. And Scott is working and Blair's trying to work on a better proof of concept. But for now, I'm going to show you the code execution on this bug. But DEP is disabled, so I'm not trying to defeat any memory security protections. And of course, the thing which we are doing is to try to make it exploitable. So an interesting thing which I noticed looking at the Corland our website, there's an article about heap spraying. And so the technique, the main point of that article is that you have to get your heap spray as precise as possible to actually bypass some of the memory security protections. So we are still not in that stage, but I guess that's interesting to show you anyway. So I'll try to do a live demo on this one now. So I got my Firefox, it's here. And the debugger is attached. I want to show you before is so this is the child, and again this is the same one that you saw before, but I want to show you this is a little bit different from the one I showed you before. Sorry. Wrong one. Sorry, must be this one. So this is the parent one. So what's happening here is this is the spray. This is a simple spray, if spray, which is done, and then the do close function. It's making the click on there are two windows which are open, so there are two children. Before I said there was only one. We had to create two windows in this case. This is just to show you how complex it is to trigger the crash. So in this case, the second window, there is a click, then the spray occurs, then on the other window, another click, and then close the first window. And that's what happens. So I'll try to see if it works. It doesn't crash most of the time. Like on 5 times, it crashed 2. So that's why we had so struggled to understand what's going on and to actually make a better exploit. So hopefully that works now. So this is, so you see the file open dialog spawn. Now if I check here, it should actually, you see the crash. But this is failed because in the heap spray we put that there is a breakpoint. So we should see the breakpoint. So I'm going to try to run again, see if I get lucky. So this, you see the crash here again, doesn't really trigger. Now it's just calling nothing. I'll try again. Yeah, failed again. Try again. Hate this bug, seriously. It's an awesome bug, but at the same time it's so difficult to. Yeah, it doesn't want to work. Try last time. No, that didn't work. So yes. So basically what happened here was about to set the breakpoint, and then it just spawns the calc.exe. Since the dep is disabled, then it would just execute the heap spray directly. All right, time to introduce other bugs. So this is a bug I found in Imaxcom. There are different bugs. This is 0 days. I'm releasing 5 of them, and those are unpatched for the latest version. So the vendor response here is 0 on 5. I send the report to them, try to chase them, no response. And there have been 11 new releases since I sent the security report to them. One bug was silently fixed, so I decided, okay, I'm going to drop these all days back in the box. So the approach here was completely different. I didn't do any factoring here. It's more like looking for injection points. And the type of bug is a different type of bug which can be found in browsers. It's called cross-context scripting or cross-zone scripting. This is like a definition which was used in some bugs that were found in Internet Explorer 3-4 years ago, and also in Firefox when you have injection in the Chrome zone, which is the trusted zone in Firefox. So basically, in few words, cross-context scripting means you have a kind of cross-site scripting, but between 2 different zones. One is untrusted, with like internet, and then the other one which is trusted. And when I say trusted, it's the browser privileged zone which have access to APIs. So just to give you some example, like if you see on the bottom, Firefox has got Chrome, Chrome has got Chrome, Opera, and Maxcom's got Imaxcom // These are all privileged browser zones. So what that means, if you're in that zone, if you have JavaScript running in that zone, you can access all the internal APIs. Like you can talk to the file system, you can talk to the operating system, you can access bookmarks, you can do things which are require privilege. So I've done some research on the past, like in October 2008, I released this Opera cross-site scripting to the Opera history page. And my exploit was to basically just dump all the history and send it out. Well, when I did that in full disclosure, 3 people jumped into the discussion and say, it's the only thing you can do, just read the history. And at that time, I wasn't really understanding what I was doing. And I say, yeah, that's what I found. And so Kuza55 say, well, you're in Opera config, so sorry, you're in Opera history, so something you should be able to do something more. And so the other 2 guys, Stefano Di Paolo and Ravi Fraf, entered in the discussion. They helped, and they found a way to basically jump from the Opera history into the Opera config, and then change the browser configuration, and then get code execution. So that was quite shocking for me because I thought, oh, wow, I just found a cross-site scripting, but then now it turned out to be a code execution, which is quite shocking. But at the same time, that was a lesson learned. So I didn't want to do the same mistake now with Maxcom. And other research I've been doing is Firefox add-ons with my colleague Nick Freeman. And the main point of our research was to find bugs in the Firefox extension add-ons. Any injection in those will result into the Firefox Chrome trusted zone, and then again you could have code execution. And the other thing about this kind of bugs is the exploitation. Like, it's 100% reliable because this is not memory corruption bug. This is layer 7, is the application layer. Any JavaScript which it's triggered in that zone will be reliable. Okay, let's talk a little bit about Maxcom. So this is developed in China. It's Maxcom International. And it's kind of a hybrid browser because it supports both the Trident layout engine and also the WebKit. And basically the entire focus of this browser is just performance and giving extra features to the users. So according to Maxcom, there's a lot of people using it. Under 30 million users, 500 million downloads in 2010. But I think the most interesting part is the scores there. You see the screenshot there. This browser is just focusing on performance. And if you go to the HTML test website, it scores more points than Chrome. So this is just to give you the picture that the Chinese are trying to get their browser more performing than the standard browsers. So this is the bugs I'm going to present today. It's a mix of different things. So the cross-context scheme thing, which I just introduced before, in in 4 different points. And then there are other bugs, which is I will mention about. So chaining all these bugs together, it gives me 5 different ways to get code execution in this browser. So let's start with the first 0 day. So this is that's an interesting one. So you can do the injection after the location.hash. The red part you see there, it's the malicious payload. That malicious payload, it's rendered into the about history. Again, that's something very similar to the Opera history bug I found. But the most important thing here is that payload, it's rendered in the about history. Then the malicious page.html does a redirection from the internet to the about history to trigger that content which has been injected. Then another way, that's the second 0 day, through RSS. Like the injection is possible in the title, link, and description tag. And in Imaxcom, you can preview RSS, or you can subscribe. So both components are vulnerable to the same bug. Bookmarks. So you have a bookmark like that. Say okay, and you see the URL. There is nothing wrong with the URL. The problem is on the title, and on the left side, something that you don't see. There is my injection. That injection will be rendered into the bookmarks zone, which is kind of privileged. And then you have other bugs. So like Imaxcom allows people to, from Imaxcom you can launch other executables. So it's kind of a feature for them. So if you do window open cmd32.exe, if pop-up is not blocked, cmd would be called. And then you have same origin policy bypass, like from window.open, you can directly call file. So that's chaining these bugs all together, give me all these bugs. Another thing which I found yesterday, which was shocking. So by default, when you install Imaxcom, it will redirect to this page, imaxcom.com. And what I noticed that when you go to that page, I don't know if you guys can see, but there are 2 tabs, last visited pages and most visited favorites. So this page is on the internet, and it's displaying information which are internal to my browser, which a web page on the internet should never be able to retrieve or to read. And that's the problem. And if you see I just launched the inspector, you see there are 2 window DOM objects. One is the runtime, and the other one is Imaxcom. These objects are privileged, and they allow you to basically interact with the operating system or the browser. So the bug here, it's interesting because imaxcom.com is a trusted domain, and it's the only domain where such DOM objects are available. So the thing is, there is no control of the resolution of the domain name. And there is no SSL, so by default it's over HTTP. So basically what is possible to be done is a man in the middle. Like if there is a DNS poisoning, you can resolve imaxcom.com to another IP you control, and there you can have JavaScript invoking such objects and then compromise the user. Or you can compromise the user over HTTP using a malicious proxy. Or if you have a cross-site scripting into the real website, imaxcom.com, again, you can totally compromise the user. And now it's time for demo. So I'm going to close that. So this is the Imaxcom browser. Click on the smiling icon, and that's the version. This is not the latest version, but it's the version I'm going to use for the demo. But also the latest version is vulnerable to the bugs I'm going to show you. So this is the first one I show you. This is the injection, the About History page. So you click there, and just to show you what's happening here is I'm injecting after the location hash. And what I'm doing, I'm using the Imaxcom DOM object, and then I'm creating, allows you to create files. So you create a temporary file, create test bat, and then what I do, I write something inside, which is cmd kdir, and then I launch the file which I just created. This is possible by just using the DOM, using JavaScript. And so now I'm just clicking here, but not, basically how it works is just fool the user to go to a web page, and the exploit will trigger automatically. So this is what happens. So you click there, it's on. You see two shells because, I'll show you. The injection occurs 2 times in the About History page. So the same payload will be triggered twice. And this is the page which is basically doing the redirection here. And I need to do that because I need the user, the browser to go to the About History so that the injection is triggered. And this is the injection here. I'll see if I can show it to you. Sorry, skip. Don't know if I, yeah. So expand the history item. Yeah, you can see here, you can see the injection. So what I'm doing, I'm injecting a picture. The picture never gets loaded. And then based on the error, there's the event handler, then triggers the malicious JavaScript. And occurs here also in the link part. So that's why you see two shells spawning. All right, I'll close this. Okay, second one. This is the RSS. So I'm going to show you first with the, again, this is just showing, I'm not subscribed to the RSS, just previewing the content. And that's it. So the picture is here. So now I'm going to click here, and just for the proof of concept, this is showing me where I am. And that's what I said before. The MX is a privileged zone. So JavaScript occurs here, and then again, you can call all the privileged APIs, and you can do whatever you want. You can also subscribe. Let's see if it works. This again, so this is a different module in Imaxcom. So if you subscribe here, and let's say that someone then changed the feed or put a new entry, then you can compromise the user whenever the feed checks for a new update. It's funny enough, I think I do have, yeah. So there's a story about this. So I left my Imaxcom, I was very tired. I left Imaxcom running with the ISS open. And the morning after, I woke up and I saw like 20 shells. So what it does is like it keeps checking for updates, but it keeps reading the same article, even the old one. So the injection occurs every time. So I was still spawning shells, and yeah, I couldn't believe it. Actually, I think I have a screenshot here and see if I can find. I don't know if you guys can see that. That's all the shells there. That was amazing. Couldn't believe it. All right, let's close this one. That's the other one. So this page, you go to this page, it will prompt you to add this favorite, to add the bookmark. The problem is not here. This is okay. The problem is here. So you notice this is Google, and then if you go on the left, that's where is the problem. So you can put your injection there on the left side, and then you can put some padding to actually fool the user to click OK. When the user click OK, then you click here, and now it's not working. I don't know why. But basically, what happens is when you click on the bookmarks, the executable should launch, and basically it's, yeah, I read, again, you compromise. I'm not sure why it's not working now. And the last bug is this one. So this is the page, sorry. So I'm in test.com, okay? This is the page. Now, I'm assuming that my DNS has been compromised, that Imaxcom points to the same website of this page. So in this case, it's localhost. So if I do imaxcom.com here on the same page, that's the problem. Like, it's a trusted domain. It doesn't matter what IP is resolving to, and it's just have to be imaxcom.com as the document domain. And if you see, check here. It's a valid website, but it's resolving to my localhost. There's no HTTPS, it's nothing. And why the shell is spawning is, like, if you look at the source code here, and that's because I'm using the script, and I'm just legitimately calling the Maxton privileged DOM API, and that's why it works. And that was shocking, seriously. I couldn't believe this one. All right, let's get back to the station. So let's keep shopping for bugs. This is the Almond Browser. That's a different one. Another Chinese browser, and I'm going to drop 3 0 days here. They are unpatched as well. It's the same story, 0 and 5 for the vendor rating response. Try to contact them. There is a form, so you have to subscribe to the form. If you didn't write never before, you have to send 10 posts to be able to contact the administrator. Then once you have the administrator contact, then I try to find a security contact. They gave me that, so I send the report. And then they say, okay, thank you, that's it. Then I chase them and say, look, can you give me a response or something? Nothing. So again, I'm going to release all these bugs. This is interesting because this is another kind of hybrid browser. So there are 2 versions. One is the Lite and one is the Ultimate. So Lite is based on you need to have Internet Explorer to have Almond Browser. The Ultimate, you might actually have Firefox or Chrome as well. But what I found very funny from the FAQ page is, like, is Almond Browser a secure browser? And the responses say, yes, Almond Browser is secure. Since it's based on Internet Explorer, Almond Browser is secure as Internet Explorer. It's kind of delegating security to the other browser, but that's not true. And just to give you some stats, I just checked on download.com. This browser has got 26 million downloads. And in download.com, it's got more downloads than Chrome, IE, or Opera, which is kind of indication to me that's used, I guess. And it's very popular in Asia, probably in China. So a little bit how it works. What I noticed when I launched it is that the main parent is the Almond.exe, and then it will call Firefox.exe. Firefox.exe is not the real Firefox.exe that you have in your system. It seems to be like a wrapped version, and it's under the Almond Browser folder application. And then you see in the yellow side, I don't know if you can read, but there are some numbers, some integers. They are passed as arguments to the Firefox.exe. So this is showing the kind of hybrid approach they took. So they have Almond on the top, and then call Firefox.exe, which has been modified to work with Almond. And yeah, other interesting stuff which I noticed, there's a res resources folder. Inside that, there are some files. So I was trying to map these files to privileged browser zones, and I found that om.tpl is matching browser home, or rss.tpl is matching browser localhost. And what I noticed this page is the use of this function, which is af run command, and that function is privileged, so it can only be used in those pages, or in the browser colon special zone. I've been trying to test this function and say, look, let's see what it does. And it's very difficult because if you try to do try and catch, if you try to catch the error on that function, like you pass one argument and you see what happens, there is no error back. This function is undocumented. You can't find any reference on the internet about this function. And it seems to me like it's an internal function, which is, Almond doesn't want to put any documentation about it. But what I noticed in these pages, which come by default, is that like if you provide like 60,003 as an integer, as the argument to that function, it will contain all the history. So, and then I try blindly to understand what you can do with that function. So I tried different values, and like if you pass 3, it would just spawns an empty tab. Or if you pass 10,025, it would just search for the argument that you used. So it's kind of interesting stuff, but I couldn't get a way to understand if I could achieve code execution. So here are the bugs. Same origin policy bypass in the browser home zone, and then again cross-context scripting, browser home, and store cross-site scripting into the feed reader. So this is the proof of concept of the history stealing, which I will demo about. And you have an iframe, okay? This is a page on the internet. You have an iframe. The iframe points to the browser home. Then you create a reference with window from the window DOM object, and you point to the iframe, and then basically you call directly that special function, and it works. So basically, it's a total bypass of same origin policy. In this case, as you can see, I'm passing 60,003. That's the same value for the history. Okay, so this is the second bug. Similar to Imaxcom, but different injection point. So instead of injecting on the location hash, in Avant you inject from the title of the page you're visiting. So if the title is like that, you have AA, and then you can escape and put your injection there. Then when the user goes to the browser home page and clicks on the tabs for the history, injection is triggered. And then again, ISS is the same stuff for Imaxcom. I'm not going even to cover this, but it's the same. Even the same parameters are vulnerable. It's title, link, and description. So I'll show you some demos as well. Sorry. Yeah, this is again, the user goes to the page and then the exploit occurs. So this is my history. I just got one item. But that's just showing you that from a page I'm on test.com, I'm just reading the history. And that's kind of the problem with this browser. I'm not going to demo on the other two bugs because I don't think I have enough time. All right. Cool, okay, let's keep going. Another bug which I found in Firefox, this has been patched some time ago, but it's worth mentioning, yes, because it's part of this research we have been doing, trying to find bugs. This was found in Firefox. It's a clearance sale because it's been fixed. When the response is 3 on 5, the only thing which they did funny, I don't know why they said I was a Mozilla security developer, but I'm not. I tried to get that rectified, but I don't know, they didn't want to change, so if you check, it's still there. And the way that this bug was found is because we found different bugs in add-ons, and one add-on developer was complaining, was saying, oh, that's strange you found bugs, because I'm following all the guidelines from Mozilla. So how did you find the bug? How that was possible? So the problem is this function, which is the NSI scriptable unescape HTML parse fragment. This function is used, and it's recommended by Mozilla, to filter untrusted HTML payload. So let's say you have an add-ons, and you want the add-ons to interact with a page on the internet. You use this function to filter the page and then do things with your add-on. So there on the screenshot below, you can see an example, like you have payload. Payload is your untrusted HTML, and then you have fragment, and then you basically use the parse fragment function to filter the payload, and the result of that, it's filtered, so it should be safe to use in the context of the add-on. So I was very curious about the comment of the developer, and I say, okay, let's try. Let's say that payload is the payload you see there, test, and then there's a script. And then run the parse fragment function, see the result, and then you see that the only things which remains test is basically removing all the script. Because again, if you have a JavaScript injection into Firefox Chrome zone, again, you can do things like code execution. So script is stripped out, which is good. But then I found this, like a different variation of the payload. But instead of putting straight script inside the HTML payload, I say, what if we have JavaScript into the href attribute, for instance? .that. Is that stripped out? Is that filtered? And what I found is that not stripped out. And that's quite interesting because if you have that kind of condition, then if the user clicks on that link, then the JavaScript which is there will be executed in the Firefox Chrome zone. And then again, you can get code execution in that. So I'll show you a demo of that add-on that we found vulnerable and the guy was complaining about. Let's see the video here, which is easy. So this is the width RSS you see on the left side, and this is the malicious RSS feed. So here my colleague Nick Freeman is setting a listening port, 666. And then you see this is the user interaction. It clicks on that. It clicks on that, and then it's got the reverse shell. And this is the example of vulnerability in a Firefox add-on. Since it's interacting in the Chrome zone, you can do pretty much whatever you want. In this case, Nick was downloading an executable, and then the executable was connecting back to his listening port. Okay, another one, Opera use after free. This is low severity. It's a memory corruption bug, and it's a clearance because I couldn't find the exploit. And vendor response is 1 on 5. It's quite interesting because I send the report to Opera and they say, okay, thank you, but this is not a security issue because you're not providing the exploit. And I say, and I said, okay, can you help me? Can you share debugging symbols so I can understand what's going on? Say no, okay. Can you check if it is exploitable? So they went back, they did their analysis, and they said this is not exploitable. But then the same guy say, but if you find the exploit, please let us know. And then I say no. If you say that it's not exploitable, then I won't spend any time to understand if I can find the exploit. And it's kind of failed because there was another guy who found the SVG font bug in Opera. So this guy released the report. Opera said, you don't have the exploit, same history. But the guy, after 6 months, found the exploit and released it on full disclosure. So that's quite a fail for Opera. So the bug was found kind of using our own factors. And I'll show you, I don't know if you can read, probably try to do them. Basically, this is a simplified test case. On the bottom, there's only 2 HTML elements. And what I'm doing with the JavaScript is basically clone the object and then basically remove the object and then append a reference. And this is done like 4 times. And it's done on the first HTML element, the M1. And then I do a IP spray, and that causes the crash. So it's quite an interesting condition. I couldn't find exploit. I tried to share that with other colleagues, other friends. They couldn't find, but it's probably worth to mention. And I'll see if I have probably have the video as well. Yeah, this is I'm just showing here the payload. So these are the 2 HTML elements. And then you have crash function. And this is what's happening. It's trying to clone the object. So I'll show you. You can see here it's like clone object, remove object, and then append reference. And basically this is what, just calling some of the methods that you can call against DOM nodes in the page, like clone node, remove child, and then append it. So again, this is a simplified test cases. My JavaScript I wrote for faxing Opera was more and more complex. It was doing more and more operations. So in order to get to this point was not that easy. So here I'm attaching the debugger to Opera and then just launching Opera against that test case. And this is the page. I don't know if you can see it, but then you can see the fee. So Opera agrees it's a use after fee, but again, it just say that's a crash. But they did fix it. And that was fixed in 11.52. All right, last section of the presentation. It's really minor bugs, but still proving the point that cross-context scripting can occur via bookmarks. And I'm going to show you in both Firefox and Opera. In the Firefox one, this bug has been it's been reported by someone else. I tried to find by who, but I couldn't find any reference. But it's totally this behavior I'm going to show you now doesn't work anymore from Firefox 11. While in Opera, this is possible in the latest version. So the approach here was looking at the injection in and from the bookmarks, see what I could do if someone, we assumed someone has a malicious bookmark. So this bug is nothing new. This has been reported like 7 years ago by this guy, Michael Cracks, to Mozilla. Basically say, oh, you shouldn't allow JavaScript URI scheme to be bookmarkable. But the story is that the JavaScript URI scheme has been invented for that purpose, to be bookmarkable. So there was a kind of discussion in Mozilla. So let's say that a user bookmarks a malicious bookmark. What happens? That's interesting. So what happens is that we might have a universal cross-site scripting. So let's say the user is on Gmail and then clicks on the malicious bookmark. What happens is that you might have JavaScript running into the context of Gmail. That's what happens. That's the impact of this problem. Even worse, let's say the user, instead of being on gmail.com, is on a trusted or privileged browser zone, like opera:config. Then the JavaScript runs into opera config, and then you can get the code execution. And that's what I'm going to show you. The reason why I'm raising this point is even if you require the user to do multiple steps, there are things you can do, like you can fool the user, like you can fool the status bar, you can spoof the URL bar, so you can spoof all the user interface controls, which allows a user to make a decision whether to bookmark or not something. Plus, JavaScript can be compressed, can be obfuscated. So to the average user, you might just say, yep, I bookmark it, and that's it. So again, this is, I'll show you a couple of demos. Brendan Haig is the guy who created JavaScript URI. And I found this discussion because he was involved. And he said there is nothing wrong with using JavaScript URIs in Chrome. What's good for content is good for Chrome often enough, but it's completely wrong. And I'll show you right now. Okay, let's start with the Opera. Okay. So this is the problem. So I have this link, and I don't know if you guys can see on the bottom there is this http://google.com on the status bar. If I right-click there, I bookmark, and this is the only thing which the user sees. So if the user is quick in his action, it's going to click OK. If the user is careful, it's going to check for the address. And this is obviously, this is not google.com. This is something else. So again, this requires multiple steps. So the same here, same technique is used. Sometimes you might have even the window covering the part of the URL bar, so it's even more difficult for user. But let's assume the user say, okay, I'm gonna do it. And so the bookmarks now is here in under Google. The problem I'm just raising is this. So let's say the user is here, and it's doing this stuff, it's modifying the browser, and then that's why different steps, and then clicks here. That's what happens. And that's a problem because the JavaScript occurs in the Opera config. The Opera, in this case, what I'm doing is changing the preference for the software, the mail software, and then do a redirection to the mail to URI scheme. So mail to will invoke calc.exe instead of Outlook or whatever is specified by default. Okay, let me show the same kind of attack against Firefox. Again, here, you see, it's the same problem, like mozilla.org, but this is not mozilla.org. And let's say we do bookmark this link. In Firefox, I think it's even worse because you can't see the URL. So it's like you just based on that, say, okay, we save it. Now in Firefox, it's a little bit different. Let's say the user is using an extension. This extension is FireFTP, okay? As you can see, the extension can read into my file system and can read into my folder. What's to notice here is the Chrome. I'm in Chrome, okay? So what happens if the user is working with these add-ons and then goes here and says, oh, I want to go to the Mozilla website? That's what happens. You got the code execution because, again, the JavaScript occurs into the Chrome zone, and you got the code execution. So this has been fixed by Firefox in version 11. So this is no longer possible, which is good. Seems that someone else has reported this bug. So that's pretty cool. Okay. So conclusion for the talk. Yeah, basically the main points. So disclosure fail. Like, it's 2012 and it's still difficult to talk and have a dialogue with browser vendors. And what I'm referring to, especially with the Chinese ones, I was shocked I couldn't get even a response like, yes, we're going to fix the bugs. Yes, thank you. These are the bugs. We confirm the bugs. There was no response, and I tried to chase them. And the other thing with Opera is kind of if you want to, it's like you have to negotiate for your bug. If you have to take a comparison with Google Chrome, like if you send use after free, you find Google Chrome, they will say thank you, and if you provide evidence it's a memory corruption bug, you might even get a reward. It's a completely different attitude, and the same with Mozilla. So I really don't understand why some vendors still don't understand this point. And then the other thing about competition is the bug complexity versus impact. So often there's a lot of focus on crazy bugs, which is memory corruption bugs. But at the end, look about the injection ones. These are very simple bugs, the one I showed for Imaxcom and Almond. And it's just, at the end, it's just an injection attack which occurs in a trusted zone. So definitely you don't need to have a memory corruption bug to get code execution in browsers. And kind of proving these points. And again, the other thing which was interesting is the delegation of security. Like Almond Browser said, yes, this browser is secure because it's based on IE. And the end user is going to believe that kind of, it's going to have that kind of assumption, but it's totally wrong. Because what they do is like, yes, they based on Internet Explorer, but then they add other piece of code on the top of that. It's kind of hybrid system. They're adding other features. And that part of the code, it's the one which is vulnerable. And so that they are wrong in saying that. And yeah, that's pretty much it. I want to thank Stackframe. He did a lot of job and work to get the Firefox exploit working and to find the bug as well. I want to thank the team at security.com. I had a lot of inspiration from my colleagues. So all this advisory, all the bugs I showed today, we're going to write the advisory and we're going to release it sometime soon. If you have any question, I think there is still time left, so you might ask now, or you can just contact me on Twitter, or just drop me an email.
Yeah, I think we have 5 minutes for questions. Okay, so if anyone has any questions, or Roberto? No? Oh, somewhere.
Hey, thanks. Thanks for the talk. Very interesting. So it seems that this couple of years, more and more people are looking to these XCS bugs, where you can actually run JavaScript code into trusted domain. And so you can basically bring cross-site scripting to code execution. I saw that some of the bugs you found have been found like pseudo-automatically, other manually. So is there a way, or do you think it's possible, like to automate this process, like to, I don't know, to fuzz the different pages and to have a plugin that visit the page and extract information from the DOM in a way that, because I think there is a large space to find new bugs there, if there is a technique to do it in more rapidly way.
No, thanks for your question. Yes, definitely that is true. The thing about automation, for the injection ones, it's very easy. So you just need the user to land to the malicious page. And if the injection is direct into the trusted zone, it's done. It's game over. For the Bookmarks one, yes, it requires a little bit of steps from the user's part. And again, that will require to find an injection which triggers automatically. In terms of fuzzing, then, yeah, it's kind of a different approach. The approach I was tweaking, basically, just to resume in one sentence, like I was just looking for cross-site scripting bugs, but instead of the website, into the browser. That was the trick to find these bugs. And if you find an injection point into the trusted zone, it's game over. You can compromise the browser. I don't know if that responds to your question.
Okay, thank you very much. I think we're out of time, so
right,
Roberto,
sorry.
I want to thank you very much for your
Thanks,
talk.
man. Thank you.
All right, and we're just going to set everything up for the closing keynote, and we'll be back in a few minutes.